Okay, ladies and gentlemen, today we're going to be looking at some things about lengths of arcs and areas of sectors. But as a way to get started, we're going to review real quick something that you should have seen previously about circumference and area of a circle. So if you have a circle, remember that the circumference is the distance around the circle. It's basically like the perimeter. So like if I was measuring circumference, it would be literally how far it would be to trace all the way around the circle. Now, remember, all the way around the circle is 360 degrees, or it's 2 pi radians if I'm measuring the turn. But I'm not talking about the turn here when I'm talking about the circumference. I'm talking about the actual distance around, which is based on a radius. So if my radius is 5, my circumference would be 2 pi r. Notice that the number of radians is the formula for the circumference of a circle. That kind of helps you remember that there's 2 pi radians in a circle because the circumference of a circle is 2 pi r. You might have learned pi d, but remember 2r, twice the radius, is the same as the diameter. I like 2 pi r. So I have 2 pi times 5 is going to be 10 pi, and that's going to be your answer for your circumference. Now, if you wanted the area of the circle, the area is actually the space inside. So if I had this circle here, we'd be talking about the inside space. So to do the inside space, the formula for area of a circle is pi r squared. So I would just do pi, let me pick a darker color, pi times my radius, which is 5 squared, which is 25 pi. Now, usually we're going to be answering in terms of pi, and that remember that means if you want to have pi on your paper, if you want pi to be part of your final answer, you don't put it in the calculator. If you wanted a decimal equivalent, you could type the 25 pi in, but if I was doing Desmos to simplify this, don't type the pi in, just type in 5 squared and then put the pi on your paper, and that will help you get answers in terms of pi. Hopefully this will help you to recall some things about circumference and area, and now we're going to extend it to arc length. Arc length is basically the distance, the length of an arc, not its measure in degrees, but once again, its length. So basically, you start by finding the circumference and then multiplying it by the fraction of the circle. So in other words, if I have a circle like this, that would have a radius of 5. We said its circumference was 2 pi r, which is 10 pi. So if I only wanted a certain part of the circle, like if I only wanted this part here, well, since this is 90-degree arc, it's 90 out of 360, so I would just take 90 out of 360 times the entire circle, and that would give you your answer. Once again, if you want your answer in terms of pi for Desmos, you could do 90 over 360 times 10. That I happen to know is a fourth. A fourth of 10 is 2.5 pi. And if you want it in terms of pi, just leave pi on your paper. If it ask it rounded to the nearest tenth or hundredth or whatever, you can put in the pi. Otherwise, don't put the pi in Desmos. Just leave your answer in terms of pi. One last thing we need to look at is sector area. It's the same basic idea. If I wanted the area of that one corner of the circle, what I would need to do is to find this corner here. I would take my area, which was, remember, pi r squared, so pi times 5 squared. The entire area of the circle was 25 pi. And since I have that corner, it would be 90 out of 360 times 25 pi. And once again, if you were doing it in Desmos, just do 90 over 360 times 25 and write the pi down on your paper. That's another one I can probably get right in my head. You'll have to check me and make sure I'm not being cocky today. A fourth of 25 is 7.5 pi. Actually, I am being cocky. It's not 7.5. It's 6.25 pi. So hopefully that helps you understand how to do this. We're going to do a couple more examples together.